Hi, welcome back guys to another video. So today I'm in the mood to do some A-level maths questions. So I'm going to try to solve a full paper that I found from this website, the official Cambridge International website. So here you have the past papers, and then you have six papers. So I'm going to issue this as pure math 1, pure math 2, pure math 3, and then mechanics and the two statistics papers. So I'm just going to be trying to solve the first, just the pure math 1 right paper. And I don't really have any particular goal apart from just killing time, really. Yeah, I just want to show you that I can teach. So if anybody come across my channel, then they will see that, oh, at least this guy can show how to solve these kind of problems. And maybe for my own personal enjoyment, like maybe one day I'll take a look at these videos again and see how much I've improved or declined. I don't know. Anyways, let's get started. So first we have this quadratic. Express 3y squared minus 12y minus 15 in this form where a and b are constants. So how do we do this? We first have to factor out 3 from this expression. So I've factored out 3. So we've got 3 and then y squared minus 4y minus 5. And then now we're going to complete the square inside the bracket, which is 3. And then we have y minus 2 squared. And now because if you were to expand this square, you would have a plus 4 at the end. But there's no plus 4 here. So you have to put a negative 4 and then negative 5. So this is 3 times y minus 2 squared minus 9. And this is 3 times y minus 2 squared minus 27. So this is the intended expression. And then B, find the exact solutions of this equation. So this equation is the left-hand side of this equation is simply the expression from before, but this time instead of a quadratic, you have a quartic equation. So instead of x squared, you have an x to the power 4, and instead of x, you have an x squared. So what do? So we let x squared be something else, like say a. So you have 3a squared minus 12a minus 15 equals 0. And now, because of the form that we found earlier, we can rewrite the left-hand side as 3a minus 2 squared minus 27 equals 0. 3a minus 2 squared equals 27. And then here we have a minus 2 equals, a minus 2 squared equals 9. So that means a minus 2 is equal to plus minus 3. So a is either 3 plus 2, or a is equal to negative 3 plus 2. So a could be 5, or a could be negative 1. Now, because we assume that a is equal to x squared, that means a here could be replaced by x squared equals 5, and here x squared equals negative 1. Now, the only equation that you have to solve is the one on the left, because at least here, you need to find real solutions. So here, the only solutions to this equation comes from x squared equals 5. So that is going to be x equals plus minus square root of 5. Could you also have done it with the right-hand side? Well, you can try actually. Like if x squared is negative 1, that means x to the power of 4 is 1. And then if you were to substitute it back into this equation, you get 3 times 1 minus, plus 12 minus 15, which is 0. So actually, this equation here could actually count as solutions, but here it is implied that we only look for real solutions. So the answer is this one. So it could have also been x equals plus minus I. Anyways, number 2. This diagram shows two curves. One curve has the equation y equals sine of x, and the other curve has the equation y equals f of x. In order to transform the curve y equals sine x to the curve y equals f x, the curve y sine x is first reflected into the x-axis. describe fully a sequence of two further transformations which are required. So from this diagram, we know which one is sine x and which one is the transform function. So here, you know that this is going to be y equals sine x. And then the other one must be y equals fx, which we don't know yet. So we know that, first of all, we have to reflect the sine x, the graph of sine x, about the x-axis. So what does that mean? The resulting graph would be this. Oh, okay, so actually it's not even. Right, so that's the result of first transformation. What two other transformations should we do in order to uh, obtain the intended function of x? So here, notice that in the f of x, in the function y equals f of x, notice that the amplitude is equal to 3. Why? So here we have the minimum point of the y equals fx is -5, and the maximum value is 1. So we know that the distance between the two, what is it? The distance between the two adjacent maximum and minimum is 6. So that means the amplitude should be 3. So the center of this other trig function should be around -2. So it's as if we have like a function where the x-axis is just like the x equals that's one negative y equals -2. So what do we do? So first, or the second transformation is to stretch the purple curve by a factor of 3. And in case you don't know what stretching is, well, stretching means to change, so to transform this graph in the purple such that the distance from each point to the x-axis is equal to some scale factor. Stretch by a factor of 3. Because this one here, the purple one, we only have an amplitude of 1. So if you want to have an amplitude of 3, we have to first stretch it by a factor of 3 in the y-axis, sorry, the x-axis. Now the third one is to move the curve. Okay, so what would it look like? So first of all, this, and then this should be around here. And there you go. All right, so that is the blue curve is after the second transformation. So now you have to shift it or translate it 3 units down. Oh wait, no. You have to no. You have to, oh no, it's 2 units, sorry. By translate by 2 units downwards. Okay. So these are the uh transformations you need to do in order to obtain the curve in the black solid line. So now find f of x in terms of sine x. So here we know that sine x is the base function. We transform it first by reflecting it in the x-axis. So that means we get minus sine x. After that, what do? You stretch the function by a factor of 3. That means we get negative 3 sine x. And then you translate by 2 units downwards, which means we get minus 3 sine x as 2. So that means the final function here is the expression we're looking for. So f of x is equal to negative 3 sine x minus 2. All right, number 3. The coefficient of x cubed in this expansion is 160. Find the value of the constant a. So in this question, the concept we have to use is binomial expansion. So 3 plus ax to the power of 6 is equal to the sum of the combination of 6, choose n. So 6 choose n, and then 3 to the power of n, ax to the power of 6 minus n, where n goes from 0 to 6. Now, this gives you all the terms required in this expansion of this expression. We're only looking for the coefficient of x cubed here. So for the coefficient of x cubed, we have to let x equals 3 because that will give us an expression where the power of x is equal to 3. So the coefficient is going to be this 6 to 3, 3 to the power of 3, ax to the power of 3. And it should be equal to 160. So, okay, what is 6 to 3? 6 to 3 is 6 factorial. All right, it's a faster way. 6 times 5 times 4 over 3 times 2 times 1 times 27 times a cubed x cubed equals 160. Actually, I'm not going to use x here because we're looking for just the coefficient. So now cancel these out. So you have 540 a cubed equals 160. So a cubed is equal to 160 over 540, and this is equal to 8 over 27. So that means a is 2/3. Hence, find the coefficient of x cubed in the expansion of this. Okay, so to find the coefficient of x cubed in this new function or in this new expression, we have to notice that in this expansion, you will have terms with 0 power of x all the way to 6 power of x. So like you will have x to the power of 0, x to the power of 1, x to the power of 2, blah, 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 blah. I think I'm going to write x to the power of 3 here, all the way to x to the power of 6. And then you have 1 minus 2x. To find the coefficient of x cubed alone, you have to notice that when you multiply this expression using the FOIL method, you're going to have a combination of terms. So how do you get x cubed? X cubed can be obtained by multiplying the coefficient of x cubed here by the coefficient of x to the power of 0, which is 1 on the right. And also having the coefficient of x squared times the coefficient of x on the right polynomial or on the right term there. So what do? So we first need to find the coefficient of x cubed, which is given already. So coefficient of x cubed in the left polynomial is 160. And then the coefficient of x cubed, x squared is 6 choose 2, 3 squared. Oh, no, sorry. 3 to the power of 4 because we want 3 to the power of 4. And then a to the power of 2. But we know that A is 2/3. It's going to replace it. So 6 choose 2 is 5. 6 times 5 over 2 times 81 times 4 over 9. So this here, and then this here. So 30 times 80. Sorry, 18. 30 times 18 is 540. So now this is the coefficient of x squared on the left polynomial. You will still have to multiply this by the coefficient of x on the right polynomial. So the total coefficient of x cubed here is 160 minus 540 times 2. So this is 160 minus 1080, and you get negative 920. Okay, number 4 is a fully calculator question. Like the intended method to number 4, all of it is just simply to use a calculator. So the equation of a curve is y equals f of x, where f of x is this expression. The following points lie on the curve, and all these values have been given to correct the 5 decimal places. So to find the value of k here, you simply have to plug in x equals 2.0001, which is the value of the x coordinate in B. So k is equal to f of 2.0001. And yeah, you simply have to calculate this using a calculator. If you plug this into a calculator, you will get 4.00063. All right. The second part of the table. The second part of the question has, this table shows the gradients of the chords AB, AC, AD, and AF. Find the gradient of chord AE. Give your answer correct to 4 decimal places. So here, the gradient of chord AE is equal to F 2.1 minus F of 2 over 2.1 minus 2. So here you just plug in the values given above. So you get 4.63566 minus 4 over 0.1. And if you were to plug this into a calculator again, you get 6.3566. Right. Then now you have to do C, to use the value of f prime 2. What is f prime 2? F prime 2 is a derivative of this function at 2. But what is the derivative? What is the definition of derivative in a graphical sense? Well, it is the gradient of the tangent line. So specifically, if you have a graph like this, and you calculate the tangent, sorry, the second line, the gradient of the second line. This is called a second line because it crosses 2 points. If you move one of the points closer and closer to the other until they essentially become indistinguishable, you are getting what is known as a derivative, or the gradient of the tangent line at that point. Right. So f prime 2 here means to find f prime 2 using the table means, notice that from point F to point A, you're approaching the point A from the right, sorry. And notice that from 3, you go from 2.1, 2.01, 2.001, and so on and so forth. You're getting closer and closer to 2, but never actually approaching it. Now, you simply estimate the value of f prime 2 by noticing that the gradient of the chord, where you go from, where the second point goes from F to E to D all the way to B, goes to 6.25. If you're so you're not really expected to find this analytically, but in case you are in doubt, well, you can actually try to do this. So like if you were to do this analytically, f prime x would be, if you don't remember the function, that would be 2x minus 1 square root of 3x minus 2 minus 2. Okay, so f prime x is 2 square root 3x minus 2 plus 1 half. Oops. 2x minus 1 square root of 3x minus 2. Oh, sorry, no. 3x minus 2 to the power of negative 1 half times 3. We simply plug in x equals 2. So this here is 2 to the power of, 2 squared of 4 plus 1 half times 3 times 1 over square root of 4 times 3. So you get 4 plus 9 over 4, which is 25 over 4, which is 6.25. Okay, but here in the exam, I'm pretty sure that what the exercise meant is you have to use the table in order to get this value and not necessarily using, I don't even think you're allowed to use the actual calculator of the derivative. So I'm just going to put this here, but I'm going to erase it just so that you don't get just so that you don't think that this is a part of the solution. Right. Number 5, prove this identity. So here, what do? We can try a bunch of easy substitutions. So the first one that immediately stands out is we have a sine x. Oh, sorry, sine squared x. So in the LHS, I'm going to copy it first. Yeah, sine squared x minus cos x minus 1 over 1 plus cos x. Here, sine squared x, recall that sine squared x is equal to 1 minus cosine squared x. Minus cos x minus 1 over 1 plus cos x. The ones can cancel out like this. And then you're left with minus cosine squared minus cos x. What do? You collect cos x, you factor out cos x, and you get cos x plus 1 over 1 plus cos x. And now you can cancel out the cos x plus 1s. So this is equal to minus cos x. So it's proven that this is identical to the right-hand side. Hence solve this equation. So this equation would have been quite complicated if you don't know this identity. But since we already know, we know that the left-hand side is actually 1/2 of the right-hand side of the question A. So sine squared x minus cosine x minus 1 over 2 plus 2 cos x is equal to 1/2 of sine squared x minus cosine x minus 1 over 1 plus x. So notice that this form here is identical to the one above. So this is actually minus cos x. And notice that this is equal to 1. So this is actually minus 1/2 cos x equals 1/4. Cos x equals negative 1/2. And this is a very easy one. So the only two values of x which has a value, cosine value of negative 1/2 is 120 degrees and 240 degrees. Actually, no. Okay. Number 6. The function f is defined by this expression for x less than 0. The diagram shows the graph of y equals f of x. On this diagram, sketch the graph of y equals f inverse, the inverse of fx. And I have to show any relevant mirror line. So here we have to remember that when you draw the inverse of a function where it exists, the graph is mirrored about the line y equals x. So first we have to identify that this is mirrored. The what is it called? The graph of y equals inverse f is mirrored about the line y equals x, like this. And now for some details, notice that the function is like this. This function has an asymptote. If you put very large negative values of x, so like very small or very large negative values of x into this one, you notice that this part here becomes close to 0, but it will never reach 4. So I'm going to give the asymptotes a different color. And this here is y equals 4. And then it also has a vertical asymptote where, notice that the denominator has x squared. So the denominator cannot be 0. That means it also has a what is it called again? Asymptote, a vertical asymptote at x equals 0. All right, so what do we do here? Well, because the graph of inverse f of x is the mirror image of the graph that is available to us about the line y equals x, what it means is in the new graph, the y coordinate of so this here would be x comma f of x, right? In your new graph, it would be f comma fx, like this, comma x. And in case it's a bit confusing, it'll be like this. So like the x coordinate is f of x in this one, and the y coordinate is x. So what do you do? That means your graph would be something like this. Wait, I'm going to give it a different color. And this graph the new graph has a vertical asymptote at x equals 4. So this here is the graph of f inverse x. You can see this by inspection. Okay. Now, find an expression for f prime, f inverse x. So here we let y equals 2 over x squared plus 4. We rearrange it so that we have an equation that says x equals something. So now we have 2 over x squared equals y minus 4. I'm gonna have to change the way I write 4 because it's a bit indistinguishable from y right here. Okay, and then you have x squared equals 2 over y minus 4, and x is equal to plus minus square root of 2 over y minus 4. Now, because the function is defined for x equals, for x less than 0, that means we have to pick we have to pick between these signs, how to make x less than 0. So we cannot pick the positive sign because this expression here is a square root, and square roots cannot be square roots cannot be negative. So you have to pick x equals negative square root of 2 over y minus 4. Now, this here is f inverse y. So that means to get f inverse x, you simply change the variable here from y to x, and you get minus square root of 2 over y minus 4. And here we can see that, oh, sorry. And here we can see that it has an asymptote at x equals 4. If you move x to be as large as possible, then the inside of the square root will get closer to 0. So actually something like so actually you have to make it something like this. And then like just imagine that this part of the function just approaches the x-axis indefinitely. All right. Now solve this equation f of x equals 4.5. So recall that f of x is 2 over x squared plus 4, and this has to be equal to 4.5 or 9 over 2. So 2 over x squared equals 1/2. X squared is equal to 4. And that means x is equal to, well, under normal circumstances, this will be x equals plus minus 2. However, since we define f of x to only be defined for x less than 0, that means we have to pick only the negative value. Since f of x is defined when x less than 0, the solution is x equals negative 2. Now, explain why this equation does not have any solutions. This here can be reasoned by using the graph that we drew earlier. So basically, by inspection, we know that f of x here, which is only defined for x less than 0, cannot have any common points with the, what is it? Can have any common points with the graph y equals f inverse x. So in this case, we can say that they don't have the solutions because the two, or rather the graphs y equals f inverse x and y equals f of x don't have intersections or don't intersect each other. All right, first step. In the diagram, AOD and BC are two parallel straight lines. Arc AB is part of a circle with center O and radius 15 centimeters. Angle BOA is theta radians, which we don't know yet. Arc CD is part of a circle with center O and radius 10 centimeters, and angle COD is pi over 2 radians, or 90 degrees. We have to show that theta takes this specific value in radians, correct for all places. Okay, so let's take a look at the facts that we have. AOD and BC are two parallel straight lines. That means AOD here is parallel to BC. And notice that CO is perpendicular to AOD. That means CB should also be perpendicular to to CO. Meaning this triangle, BOC, is a right triangle. Now, we can also fill in the details. This is 15 centimeters because AOB is part of a circle. It is, arc AB is part of a circle. And then CD is also part of a circle. So this is also 10 centimeters. All right. So how do we find theta? Well, we don't know how to find theta yet, but we can use we can try to find this angle, which we will assume to be, let's say, phi. Okay, so actually, okay, if I don't want to overload you with symbols. I'm just going to say that angle BOC. Now, you have consider this angle, right? Consider this angle. If you take a look at if you focus on a triangle BOC or BCO, whatever you call it, you notice that you have the adjacent side and the hypotenuse side. So what trigonometric ratio uses the adjacent side and the hypotenuse side? That's right, the cosine. So the cosine of BOC is equal to 10 over 15 or 2/3. Now that means angle BOC is equal to our cosine of 2/3. Okay, so this is our cos, or depending on your notation, you would say cos inverse. I don't really like using the cos inverse notation, even though it's a bit more practical and maybe shorter. It isn't exactly the best notation, in my opinion. All right, so now notice that these three angles must be equal to 180. The sum of them must be equal to 180. So we have theta equals, oh, sorry, theta plus r cos 2/3 plus pi over 2 must be equal to pi radians. So theta is pi over 2 minus 2, oh, sorry, minus r cosine of 2/3. And if you plug this into a calculator, you should have the intended value. Four 0.7297. Okay. Now find the perimeter of the area and the area of the shape ABCD. Give your answer to correct three significant figures. Okay. So first, let's find the perimeter. If you take a look at the perimeter, sorry, if you take a look at the shape here, the perimeter is the sum of all the outside, the length of the outside, what is it called? The length of the outside parts. So that would be AOD, which is just AD because they're on a straight line, then CD, then CB, then BA. So the perimeter is simply the sum of AD, which is a line, and then arc DC, and then CB plus BA. Okay, so AD is a straight line, and it is made up of AO and OD. That means the salt is 25 centimeters. I'm going to put the units at the end. What about DC? DC is the quarter arc, sorry, the arc of a quarter circle. That means it is going to be pi times, sorry, pi over 2 times 10 centimeters plus the length of CB. The length of CB can be found using the Pythagorean theorem. What is it? So here, CB here is the other leg of the triangle, and you find it using 15 squared minus 10 squared, which is equal to square root of 125, or 5 squared of 5. And then BA here is the BA is the arc with the central angle of theta, which we found to be this. So you have theta times r, or the r here is 15. Okay, so you get 25 plus 5 pi plus pi squared of pi plus 15 theta. And this should be equal to 62.8 centimeters in 3 significant figures. What about the area? For the area, you have to find the area of each shape that makes up this entire shape. So you have the area of the arc, the sector AOB, plus the area of the triangle BCO, and then area of COD. So area of AOB here is theta over 2 times r squared, in this case, which is 15. So theta over 2 times 15 squared, plus area of BCO is 1/2 times the base and the height of this triangle, which is the base is square root of 125 and the height is 10. So we have 5 square root of 5 times 10. And then you have area of COD, which is a quarter circle. It's going to be pi over 4 times 100, or 10 squared. So here, 225 over 2 theta plus 25 square root of 5 plus 25 pi. So that means the total area, using this, plugging this exact value into the calculator, we will have 217 centimeters squared. All right, number 8. The first 3 terms of an arithmetic progression are 25 for p minus 1 and 13 minus p, where p is a constant. Find the value of 10th term of the progression. So because these are the terms of an arithmetic progression, and they are the first 3 terms, that means this is the first, second, and third. So in an arithmetic progression, the common difference between 2 successive terms are equal. So that means 4p minus 1 minus 25 should be equal to 30 minus p minus 4p minus 1. So let's translate that into the equation that we need. So 4p minus 1 minus 25 is equal to 30 minus p minus 4p minus 1. So 4p minus 26 equals minus 5p plus 12. 9p equals 38. Oh, wait, no. Oh, all right. This is 14. Sorry. This is 40. P is equal to 40 over 9. Now, remember that this is just a p. The difference is 4p minus 1 minus 25. We substitute p into this one. So 116 over 9 minus 1 minus 25, which is 160 over 9 minus 26 times 9, which is 234. And this here is equal to minus 74 over 9. Now, to find the 10th term A10. A10 is A1 plus 9 times D. So I'm just going to put D as a difference there. A is the first term, like A1. And in case you forgot, this is actually 10 minus 1. 10 minus 1, D. All right. So A1 is 25 plus 9 times minus 74 over 9. So that's 25 minus 74, which is negative 49. All right, B. The first three terms of a geometric progression are this. So this is equal, or rather, the same kind of terms are now the first three terms of a geometric progression. They're not the same terms, but they have the same pattern. Now we have to find the sum to the infinity of this progression, given the first three terms are like this. So because it's a geometric progression, we know that 4q minus 1 over 25 must be equal to 13 minus q over 4q minus 1. So we will solve this. You'll get a quadratic. Okay, now this is a quadratic, which might be complicated. You can probably solve this using a calculator, or you can brute force this using the quadratic formula. So q is equal to minus 17 plus minus square root of 289 times, plus 4 times 16 times 324 over 32. Now this itself would require a calculator. Minus 17 plus minus. This inside a square root would evaluate to 145 over 32. So Q is either, what's it going to be? 128 over 32, which is equal to 4, or Q is equal to 145 plus 17 is minus 162 over 32, or minus 81 over 16. Now, because we want to find the sum to the infinity, that means this progression should be a converging progression, meaning its ratio should not exceed, its ratio should lie between -1 and 1, not including the endpoints. So let's take a look at this. If we assume t equals 4, the first term is 25, and the second term here is 4q minus 1, which is 15. And here, the ratio is 15 over 25, which is 3 over 5. What about the other one? The other value is more difficult. If q is this, then a1 is the same, 25, but a2 is 4 times negative 81 over 16 minus 1. So you get minus. So you get, what is that? 81 over 4 minus 1. 85 over 4. Now notice that it says q is a positive constant. That means, oh yeah, you're right. Oh, we don't even need to do this actually. Oh, q is a positive constant. I thought the ratio has to be positive. No. Okay, we just wasted some time. Okay, but with that information, we can be very sure about the ratio of this infinite geometric progression. So the sum of infinite GP is equal to the first term, which is 25 over 1 minus the ratio, which is 3 over 5. 25 times 5 over 2, which is 125 over 2. Okay. Number 9. This diagram shows the product curve of the equation. Yep, that. And the lines x equals 2.4 and y equals 1. The curve intersects the line y equals 1 at the point 1, 1. Find the exact volume of the solid generated when the shaded region is rotated through 360 degrees about the x-axis. So here you will have to use the formula for the volume of solid revolution. So the volume here is I times the integral of 2.4 to 1. So I'm going to use 12 over 5 here just to make it easier. And then here, notice that because you're rotating this about the x-axis, you have to treat two functions to be fx and gx. So fx here and gx is here. So the upper function, the function that will be further away from the x-axis, is going to be f of x. So f of x squared minus dx squared dx. All right. We know f of x is equal to 1 and gx is equal to this 5x minus 4 to the power of negative 1 over 3. So the volume is this 1 minus 5x minus 4 to the power of minus 2 over 3 dx. So this volume here is, the integral here is quite easy to calculate. Oh, wait, no. So here this is pi times x minus. So for this one, you have to do the reverse chain rule. So you have to remember that this one, like if you were to derive this, or say if you differentiate this with respect to x, you'll get 1/3 times 5 times 5x minus 4 to the power of negative 2 over 3. So here in front of this, you have 3 over 5. The 5 comes from 1 divided by the derivative of the inside function here, and 3 here is because if you were to differentiate this to the power of 1/3, you will get 1/3 times this to the power of negative 1 over 3. So that's what you have to do to balance it. And then you substitute the integration bounds, so you get pi 12 over 5 minus 3/5 times 8 to the power of 1 cubed, 1 over 3, minus 1 plus 3 over 5. So this is 12 over 5 minus, so this will be 2, right? 6 over 5 minus 5 over 5 plus 3 over 5. So you get pi times 6 minus 5, 1 plus 4, that's going to be 4 over 5. So that's 4 over 5 pi. The equation of a circle is x minus 3 cubed, x minus 3 squared plus y squared equals 18. The line with this equation passes through the point 0, negative 9 and is the tangent to the circle. Find the two possible values of m, and for each value of m, find the coordinates of the point at which the tangent touches the circle. Okay, so let's draw the circle and try to sketch what is happening here. So imagine you have a circle here. The center is 3, 0. The point O, negative 9 is somewhere around here. And then when you draw a line from this point tangent to the circle, it will look something like this. Wait. So this is O comma -9. So let's say this is y equals m1x plus c. This is y equals m2x plus c. Why do we know there will be two values of m? We'll see later. Now, we are given the fact that this line passes through the point 0, -9. That means one half of the line equation is already known. Y is equal to mx minus 9, because -9 is the y coordinate, sorry, y intercept of these lines. So like if you were to draw the axis, it would be something like this. Right. Now, how do we determine the equation of the lines? Well, notice that when a line is tangent to a circle, its distance to the point or to the center of the circle, this is equal to the radius. And the radius is square root of 18 or 3 square root of 2. So what do you have to do? Now recall the distance between a point and a line. So you have this equation here is mx minus y minus 9 equals 0. So the line equation must be in this form to use this formula. So the distance between the point and the line here is m times, so you have m times 3, sorry, absolute value of m times 3 plus minus 1 times 0 minus 9 all over square root of m squared plus 1 equals, this should be equal to 3 square root of 2. Okay, just in case it's a bit unclear, I'm just going to write the reasoning a bit here. When is tangent to a circle is distance to the center of the circle is equal to the circle's radius. So we have 3m minus 9 over square root of m squared plus 1 equals 3 square root of 2. If you square both sides, you get 3m minus 9 squared over m squared plus 1 equals 18. So this here is 9m minus 3 squared over m squared plus 1 equals 18. And now you have m minus 3 squared equals 2m squared plus 1. Now I'm just going to, I'm not going to walk you through all the derivation because you probably know how to do it. So squared minus 6m plus 9 equals 2m squared plus 2 m squared, so going that way, plus 6m minus 7 equals 0, m minus 7, sorry, f minus 7, m -1. So m is either -7 or m is equal to 1. Okay, so these are the two values of m. But we're not done yet. We have to find the points of tangency. So the two lines that are tangent to the circle are, okay, I'm going to write this one. Points of tangency. So one of the lines is y equals -7x minus 9. And then the other is y equals x minus 9. Now, to find the points of tangency, you substitute this into the equation of the circle. So x minus 3 squared plus -7, x minus 9 squared equals 18. And then this one is identical. And I'm going to do the algebraic part because it's easy. Okay, so we have x equals 6 and x equals 5, 6 over 5. So these are the x coordinates. The x coordinate can be obtained by simply substituting this into the line equation. So minus 42 over 5 minus 9. This is equal to, wait. Oh no, this is 42 minus 45 over 5. This is -3 over 5. For this one, y is equal to -3. So therefore, the points of tangency is, or the points of tangency are 6 over 5, comma, -3 over 5. And then you have 6 over -3. Wait, hold on. Oh, wait, I think I made a mistake. It's a plus, it's a plus, plus. Oh, sorry, so this is a minus. That means, oh yeah, okay. There. So we have that as the value of m, and then we have these as the points of tangency. Right, last question. For the last question, we have a graph of the function 4 over x cubed minus 3 over x plus 2 for x not equal to 0. Find the set of values for x for which f of x is decreasing. Okay, for this, we have to recall that when a function is decreasing, its derivative is negative. So that means like its gradient of its gradient or slope is negative. So that means we have to find f prime x. F prime x here is equal to Just in case it's just to make it easier, this is going to be 4x to the power of negative 3 minus 3x negative 1. It's 2. So the derivative is minus 12 x to the negative 4 plus 3x to the power of negative 2. Or minus 12 over x to the power of 4, 3 over x squared. This is equal to this. And because we want this decreasing, then we have to make it less than 0. So that means we have to solve this inequality. So the numerator is 3 times x cubed, x squared minus 4 over x to the power of 4. We factor out the numerator. And then here, we'll have to use a number line to answer this. So the possible values of x that makes the expression either 0 or undefined are either negative 2, 0, and 2. And then each of these are going to be hollow because we cannot include them into the solution. Otherwise, we would obtain a 0 or division by 0. So now we test the values. We test values of x in these intervals. If x is equal to 1, then let's take it. 3 times 3 times negative 1 over 1, which is going to be negative. So this is negative. Now we know that 0 here comes from x to the power 4, which has an even degree, which means that when you cross this line here, you cross this point, the sign doesn't change. So still a negative. But when you pass through negative 2 here, because the power of negative 2, the power of the factor that results in the solution of negative 2 here is an odd number of 1. That means you change the sign. Same goes for here. So the intervals where x is decreasing, sorry, f of x is decreasing is this. So that means the interval for which f of x is decreasing is negative 2 to 0 and 0 to 2. Like that. All right, last question. A triangle is followed by the y-axis, the normal to the curve, at the point where x is equal to 1, and continue to the curve at the point where x is equal to negative 1. Okay. So this 8 marker requires you to find several things at once. So the normal to the curve, the tangent to the curve, and then the area of the triangle. Like you have to first imagine what it looks like. So let's try to find the normals and the tangents first. So for the normal, now if x is equal to 1, that means f of 1 is equal to 4 over 1 minus 3 over 1 is 2, which is 3. What about f prime? So we know that f prime is already here, which is minus 12 over 1 plus 3 over 1. So that's negative 9. Now, if you want to find normal, the gradient of the normal line is the negative reciprocal of the derivative at that point. So the gradient here is going to be 1 over 9. Now, this is the gradient, and this here the line passes through the point 1, 3. So that means the equation of normal line at x equals 1 is y minus 3 equals 1/9 x minus 1. So y is equal to 1 over 9 x plus 26 over 9. Then, what about the tangent line? F of negative 1 is 4 over negative 1 minus 3 over negative 1 is 2. So this is minus 4 plus 3 plus 2, which is 1. So the tangent will cross the line 1, 1. So the point 1, 1. And then the derivative at this point is minus 12 over 1 plus 3 over 1, which is -9. So the line has a gradient of -9 and passes through this point, 1, 1. So the tangent line at that point is y minus 1 equals -9x minus 1. Y is equal to -9x plus oh wait, sorry. This is supposed to be right. Oh, wait. But this is -1. So that's why. So that means it's going to be -9 plus 1 at 8. Okay, so the lines will look something like this. So I'm going to call this line 1, and this is line 2, just to illustrate to you how it looks like. So line 1 here has a y-intercept at 0.26 over 9, and it has a positive gradient. So like this. This is line 1. What about line 2? Line 2 here has an y-intercept at 0.8, and it has negative gradient. So it looks like this. And I'm going to mark 6 over 9. This is -8. Now, the triangle we're looking for is this area. For that, we need to know the point at which they intersect. So let's try to find it. So point of intersection is 1 over 9x plus 26 over 9 equals 9x minus 8. So this here you have 82 over 9x equals -8, -26 over 9, which is, this is 72 plus 76, 98 over 9. And then x is equal to -98 over 82, or -49 over 41. We only need to find the x coordinate because we don't need the y coordinate, because with this triangle we have we have this as the base and then this as the height, and the height is simply the distance from this point to the line x equals 0, or the x-axis. So y doesn't matter. So that means the area of triangle is equal to 1/2 times the length of the base. The length of the base is 26 over 9 plus 8. And the height is this, but taking its absolute value. So 49 over 41. And yeah, this will be a decimal because the question says that you have to give your answer corresponding to significant figures, so there will be a calculator involved. So this here is 1/2 times 98 over 9 times 49 over 41. You can cross out this, and then 49 squared over 9 times 41. And this, if you plug it into a calculator, you will get 6.51 square units. Okay, that's it. So yeah, we solved all of the questions in this paper. And I hope it didn't take too long. Okay, so that's it from me for today. Hope this is useful to you guys. I'll see you in the next video. Peace out.